this video is looking at the 2021 QCAA external exam multiple choice section. So just going through how to answer the questions so that you can see where the answers come from. So we've got a table given to us and we're asked to find the second smoothed value for the 3-point moving average. So when we do a 3-point moving average, we need 3 values. So if we're looking for a certain day, we need the day before, the day after, and the actual day that we'll add together and divide by 3. So this question's a little bit of a trick question that you have to know. You can't do day 1 because you don't have a value next to that. So it's not going to be day 1. They want the second smooth value. So the first one that we can work out is for day 2. So the second one would be for day 3. So we are then looking at, for day 3, these 3 values here that we're going to add together and divide by 3. So we're going to go 10 plus 18 plus 32, and then we're going to divide that by 3, which gives us 20, which is our answer C. Now for question 2, it's asking for how many faces does this planar graph have. Now when we're counting faces, and I'll try and get a few different colours here to show you. So when we do our faces, we're looking at what's enclosed. So this is a face, that's 1. Then we've got this part here, that's the second face, and then we've got the third one here. And then we have to remember that we also count behind as well. So this area behind is also counted as a face. So that gives us 4 faces for that question. So that gives us an answer of B, because there are 4 faces. Okay, looking at the next question, question 3. We've got a table showing us the results of a student survey about their preferred movie genre. It says, of the students who preferred comedy. So we know that we're looking at this comedy section here. And we want to say what percentage were in year 9 or higher. So we need to know the total for that one. So if we do 20 plus 24 plus 36, we're going to get 80 as our total there. And then we want to know what percentage were in year 9 or higher. So year 9 and higher is 24 plus 36. So when we add that together, we get 60. So to get our percentage, we're going to do the 60 over 80 and then times by 100. And so we'll do 60 divided by 80 and then times by 100 gives us 75%. So our answer then is D, 75%. For question 4, we've got the bipartite graph already drawn for us, and we want to then go through and work out what the allocations are so that we can answer this question here and see which statement's correct. So firstly, and I've already highlighted this one here, there's only one line going to the first runner, so the only person who can be first runner is Bilal. So we'll go Bilal is the first runner, which means then we can't use this line here for Bilal because that's the first runner. So then down here, the only one going to 4th other than Bilal is Simon. So Simon has to then be the 4th runner. So then we've got 4th runner is Simon. And so then when we look at, so we've taken Simon and Bilal, Simon's also goes to the 3rd runner, but if he's doing 4th, he can't do 3rd, which means Ivan must be the 3rd runner. And so we will highlight him for 3rd runner, which means that Lynn must be the 2nd runner. So then we go down the statements. Lynn should be the 1st runner. Well, no, that's not going to be right because he's the 2nd runner. Simon should be the 2nd runner. No, because we've got him as the 4th. Ivan should be the 3rd runner. Yep. Bilal should be the 4th. No. So our answer is C, which is that Ivan should be the 3rd runner. Okay, in question 6, we're given a range of graphs here, and we've got scatter plots showing the number of high-rises in a city and their distance from the city centre. Which scatter plot was used to extrapolate, and that's a key word in this question, that 25 kilometres from the city, there were 20 high-rises. So we can go two ways here and go, okay, this graph here and this graph here includes a value at 25. So we're not extrapolating to get to a value of 25 there. We're just reading from our graph. Extrapolating means we go beyond the values that we've got. So these are two graphs where we're extrapolating. If we read off this one as 25 and go across, we'll see that yes, it is approximately 20, but over here, it looks more like maybe 10 or less. So we would choose A that way. The other option is to look at them and see which ones read off the 20, which are these two, and then rule out that one because it's not extrapolating. So our answer for question 6 is A. Question 7 is the minimum cuts one. I know this one is not a favourite. I would class it as my least favourite type of question, but because the cuts are already drawn in, that's why I like it slightly better. So not a fan of this topic, but if the cuts are already drawn in, that's okay. So basically we need to go through and work out the maximum flow that is cut off with each of these cuts. So with C1, we have got 80 plus 70, which is going to give us 150. When we do C2, we've got the 45, the 65, the 40, and the 55. And that gives us 205 when we add them up. C3 we've got is the 90 and the 65 and the 55. And you might say, well, why aren't you counting the 40? But it's going the other way, so we don't count that one. That gives us 210. And then our C4 is going to be the 90 plus the 65 plus the 45, which gives us 200. So we can see that C1 is the smallest number, and even though we're asked for maximum flow, the maximum flow is that smallest number that can go through. So C1 is the answer. I know it's a little bit counterintuitive that where our maximum flow is the minimum number, but that's how our flow networks work, because if we're putting that water through or cars through, we can't go more than that smallest route that's there to go, because the water won't flow through. And question 8, we have got a little table here showing us rounds of a competition, basketball between 6 teams, and we want to know how many edges that we would draw to represent that if we were putting it into a graph. Now, when we see one like this, a lot of students will go, okay, well, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 edges. Boom, that's my answer. However, when we look at it carefully, we want to check, are they logging just who's won, or are they just logging that they've played someone else? So when we look over here, I checked the first one, the Bears and the Lions, we've got a tick there, but we also have a tick there. So we don't want to use that twice. So that means our 18 that we added up, we really want to divide that by 2, because that shows us the edges there, because we would only draw one edge between the two teams that play. We wouldn't draw 2, we'd just draw the 1 because there was the one game. Okay, question 9. And a few little things to note in question 9. A staircase is to be extended by installing n additional stairs. Each stair is 25 centimetres high. If the existing staircase reaches 1.2 metres off the ground, which rule models the total height of the stairs? The total height the stairs will reach in centimetres. Now, first thing is this centimetres. And we've got 1.2 metres over here. So to start with, we need to change that to 120 centimetres. Now, we've got here then the 1.45, so that's not going to work. And we've got the 1.2 there. So we know those two are automatically out. And so we're deciding between these two here. And we've got the n minus 1 times 25, and each stair is 25 centimetres high, so that should work. Here we've got the 120. Well, that's not going to work because we want to be multiplying by the 25. Some people might query why it's got 145 there instead of the 120. But we have to think about if we're doing n minus 1 and we're adding 10 stairs, 10 minus 1 is only 9, which means we have to add that first height to the original. So the 120 plus 25 gives us the 145 there. So C is our answer. for that one. Question 10. A city is located at 55 degrees north, 120 degrees east, and city B as at 40 degrees north, 165 degrees east. And the sun will rise in city A approximately blah, blah, blah. Now, we first want to look at these, and if we're looking, obviously this is a time zone question. Time zones are only concerned with those east and west values because we're looking at that kind of horizontal distance between them because our time zones go in those sections across our page. So we have got 120 degrees east and 165 degrees east. So the difference between that is 45 degrees. Now we know that 1 degree is equal to 4 minutes. So we can do that times 4 and it gives us 180 minutes, which means that gives us 3 hours. So we've automatically crossed out A and B because we've got 3 hours. Now we've got to decide, is it does 3 hours before it rises in city B or 3 hours after it rises in city B? Now B is further east than A, so it's ahead. So if that's 3 hours ahead, then the sun is going to rise 3 hours after it does in city B because A is behind B if B is ahead of A. So D is our answer there. Question 11. We've got which option is an example of bivariate data? Now bivariate data, we need 2 numerical variables. So the rating given to a brand of meat pies as poor, fair or good, well that's not going to be it because that's words. The number of people in a household and the amount of water used. So yep, that could work, number and amount. The number of cars passing through a particular set of traffic lights. Well, here we don't really have 2 variables. We've got the one set of traffic lights and the number going through, so that's not going to work. The time a person spends on a mobile phone on a Friday evening. So again, not 2 variables there. So we've got B as our answer because that's the one that has the 2 numerical variables. Question 12 we've got is which statement is correct? A minimum spanning tree must contain a loop. Well, we know that's not true. A minimum spanning tree must contain a cycle. Well, not really because we don't want a cycle in it because our minimum spanning tree doesn't have as our minimum number of connections just to get everyone in the connected at some point. Every network has only one minimum spanning tree. Well, that's not necessarily true. A minimum spanning tree has one more vertex than the number of edges. Now that is our correct one there because we only need, if we've got 6 vertices, we only need 5 edges to join them up so everyone's joined in some form. Now question 13, we want to go through and work out our minimum number of days required to complete the project. So when we see these ones, we're dividing each of these circles into 2. Not that we really need to do this, but in this question because we're only looking for the minimum days, but just for habit there because we usually will do a forward scan and a backward scan. So we always start at 0 and then we're just going to work our way along. So if we go from 0 along the A line there, we've got a 4. If we go B, we get a 5, but I shouldn't have gone and written that in straight away. When we've got 2 lines coming in, we've got the 5 and we've got the 7. So we always go with the bigger number there. Then we've got 7 and 8 is 15. 7 and 2 is 9. I can write that one in because there's only one line going into that. 9 and 5 is 14. So that means I'm going to write my 15 there. And 15 plus 4 is 19. So my minimum time required to complete the project is C, which is 19 whatever unit, days, 19 days, because we've got a minimum number of days there. Now we could also have done a backward scan if we wanted to look for a critical path in that. Question 14. A town's current population is 15,480, is predicted to grow steadily at an annual rate of 12%. The predicted population after 10 years is approximately, and we need to work it out. So when we see the 12%, we know that we're going to be multiplying by 1.12 because we've got our original amount. We're adding 12% each time. 12% is 0.12 as a decimal, and instead of doing it in 2 parts, we can just multiply by 1.12. We've got our 15,480, so probably the quickest way to do it is to put the 15,480 in, press enter, and then we're going to times that by 1.12, and we're just going to press that 10 times. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we get 48078.53, which we would round to 48079. Now, question 15 is our last one in the multi-choice. And we've got we're trying to look for the best return. Now, often they'll give you two with the same percentage but different compounding. They haven't done it on this one, which is a little bit annoying, which means we have to check all four. Initially off the bat, I would look at that and think it's probably daily, but I need to go through and check my numbers anyway. So what I'm going to do is I can either use the effective interest rate formula, or I can just sub in $100 and look at which one has the highest number. Now, when I sub in $100 into the compound interest formula for them, I get 106.1 for the first one, 106.11 for the second, 106.104 for the third, and 106.079 for the fourth one, which means that my B is the actual answer here, the 5.95% compounding monthly, actually comes out better than the daily one that I was expecting it to be. Okay, hopefully that helped you with your multi-choice questions working through in your preparation for externals.